Okay, let's look at the coordination number for FCC. So the coordination number is the number of atoms touching any given atom. Okay, so you get one atom. How many atoms are actually touching that atom? So the way I usually like to do this is I go and take a look at. I usually like to look at this right side atom here. Okay, and then what I do is I say, well, I know that atom is touching this corner and touching this corner. They touch across the face diagonals, as you know, for FCC. So that means it would be touching those. The other thing we know, though, is that this direction across the say this bottom face is actually the same direction as this direction here, going from the front face here to that right side. So you just shift it up. So it's the same, that's the same direction. So in fact, we know if the atoms are touching across this bottom face diagonal, well, they must also be touching this way. And similarly, we could say, well, if they're touching, across this face diagonal, that way from here to here is the same distance as from this atom to this one in the back face. And similarly, we could do that for, say the front faces. Well, if they're touching this way across the front, okay, then they must be touching from this right side atom to the top side atom. And that is the case. So we go like this. And it quickly starts to look a little bit messy. You see I've drawn 8 lines there so far. Okay, and if I, 1, 2, 3, 4 on that right side face, 5, 6, 7, and 8. So touching these left face-centered atoms. Well, the thing that we're not seeing here yet is that there's in fact also another unit cell with atoms the same distance as these right side 4 atoms, these face-centered atoms here, top, front, back, and bottom. And so that right side atom also touches those ones just the same way as it does. So it's going to touch this front one, it's going to touch this top one, it's going to touch that back one, and it's going to touch that bottom one. Okay, and so that makes for, I hit 6, 7, 8, 9, 10, 11, and 12. Now you look at that, and that looks like a mess. There's lines going everywhere. If you followed along as I did this in the video, I do hope that it makes some sense, but it's a messy picture to look at. Now, a student actually came to my office hours just the other day and showed me a really neat way to depict this, and so I'd like to actually show you that. So I want to back up here and show you another way of looking at this, and that would be if I say drew in for you a little square here, a plane, if you will, okay, and that's parallel to the surface of the screen that you're looking at. And then I could identify, say, another plane here, going front to back. Okay, this plane here. Perhaps I should make that a little bit larger so it's more obvious. Okay, so this one here, front to back, you see that, the blue plane. And then finally, if I chose another color, say I'll use this orange color, I could identify a final plane that proceeds in this horizontal plane, if you will. Okay. And on each of those planes, the atom touches 4 nearest neighbor atoms. So I actually really like this. I think it's a neat and clear way of depicting the coordination number for FCC. I like that. Anyway, there we go. So there's another way of showing those same 12 nearest neighbor atoms, but thought of just by slicing, in the XY plane, in the ZY plane, and the XZ plane. Okay, so the color coding actually was green here for ZY. Blue was ZX, okay, and then the horizontal one I did in the orange color. Okay. So anyway, that's another way of looking at it, but I do hope that makes it clear, the coordination number for FCC. Now, you could have done that for any other atom, but I find that right side one is just the easiest one to do because 8 of the atoms are already in the unit cell that you're originally looking at. But you could, if as a challenge, you could look at any other atom in the FCC unit cell and convince yourself that, in fact, it has a coordination number of 12. Okay, thanks a lot.